Okay, minimize there, and minimize here. Okay, what is the equation of the tangent line to f prime at x equals 3? Well, we need a point, and at x equals 3, we actually have 3. And then, to get the slope, though, at 3, we need 2 pi. Okay, so that means y equals 2 pi x minus 3 plus 3. And that's it. That's all you gotta do. All right, and now we're going to do this one on a simple sheet of paper. I wanted to give you a hint for those of you that have stuck around and are checking this out. There's a question similar. It's kind of a bonus question because this is one of the tougher ones. This is, how do we find the second derivative of something that's basically implicitly defined here, because it's not a y equals. Okay, so I'm going to take the time to do this one and kind of talk it through. And yeah, hopefully this makes some sense going through this. So let's do the first derivative. So we don't actually, it's implicitly defined. So in order to start this, you actually just go ahead and take the derivative. And so that's just going to be 2x if you're doing it with respect to x minus 2y times dy dx. Because remember, it's implicitly defined, so any other variable other than x is going to have a d something dx, always popping up, okay? All right, but that's the only y, so this guy over here ends up being 0. Cool. So now what we do is we go ahead and move that guy over there. So we got dy dx equals, we're going to move this guy over to there, so he's negative 2x, but we're going to divide by this negative 2y. That gives us positive x over y. Now that's the first derivative. Now if I want to take the second derivative, okay, what I'm going to do here is I like the product rule better than the quotient rule. So I'm going to do this one right here. dy dx equals x times y to the negative 1. It's a little easier to do, right? If you did the quotient rule, it'll work. It'll just look significantly messier. So this is kind of nice because these guys are just expressed very simply. So I'm going to use the product rule. So take the derivative of the first, but not the second, plus do not take the derivative, but then take the derivative of the second. So the derivative of the second would be negative y to the negative 2, okay? I'm sorry, this should be plus. Okay, sorry about that. That's plus, not equals. I lost my train of thought. So, oh yeah, I totally lost my train of thought. Oh no, equals is right. Equals is right. Got that. Let the derivative of the second. So this is going to be dy, but this is d2. Okay. Okay, so that's better. Okay, so here's the derivative, actually. Okay, so here I just rewrote it. So my apologies. So now this is going to be dy dx. Okay. So let's see what we got here. Okay, we've got 1 over y plus negative x over y squared. Okay, and then multiplied by dy dx, and then dy dx is x over y. So remember, if you got to go into the second derivative, you will always have to do a substitution of the first derivative, okay? Always. So watch out for that. It's like it happens every single time. So that would be multiplied like that, okay? Now, what this then does is it gives us 1y plus negative x squared over y to the third. Okay, Now we're going to give this guy two y's so that we can combine them. Okay, so that would be y to the third, oh, I'm sorry, y to the second over y to the third minus x squared over y to the third. So now y squared minus x squared over y to the third. Okay, and that is the final answer. That is the second derivative. Okay, and you can see here that they're very different than what you ended up with. Okay, so just to go over, this was a mistake here. So this should have been rewritten. And as soon as I went over here, I lost my train of thought and then thought that this was part of my derivative. So that's no good. So then I took the derivative of the first one, which is 1. That's just an x. So then he stayed there. Okay. So that's it. This is it. Yeah, so watch out for that. There's going to be one just like it on the test. Okay, and it's like the last problem.